In today's video, we want to look at numerical analysis. So we are looking at numerical analysis. You might be wondering, what exactly is numerical analysis? Numerical analysis is nothing but a branch of mathematics that we use in solving problems. Of course, in this video, we want to deal with Gaussian elimination method. Gaussian elimination method is nothing but a method that we use as a row reduction algorithm solving linear systems of equations. It consists of a sequence of operations performed and the corresponding matrix or its coefficients. So in this video today, we will be more interested on this, and I would like you to pay attention, as this will help us as we move on in terms of what numerical analysis entails and what we are expected to do in this video. So let's take questions on this numerical analysis and see how that goes. So let's take question number 1. The first question says use Gauss elimination. Use Gauss elimination method. Elimination method to solve the following. To solve the following systems of linear equation. Of the system of linear equations. So this is our questions, and we'll be likely handling these particular questions on Gaussian eliminations. So this is what we have. So we are to use Gaussian elimination to work on this. Use Gaussian elimination method to solve the following systems of linear equations. So let's take the question and see what we have in this video. So here we've got the the equations. We have 7x. We have 7x plus 3y minus z is z, and this is equals to negative 16. We have 5x plus 4y plus 2z plus 2z, and this is equals to 4. And then we have 3x minus 4y plus 3z, and this is equals to 5. So the first thing we need to do here is to have the augmented part of this equation. So we write it in the form of matrices. So we need to have the augmented part. Need to write the augmented matrix of this equation. The augmented matrix of this equation. Here we are given 7, so we write it in the form of matrix. This will be 7, 3, negative 1. We have 5, 4, and 2. So having it as a system of the as augmented matrix now will help us to work on the rows and the columns. And our target here is to make these second rows and the corresponding columns to be 0 as we find the values of x, y, and z. So let's start by working on the first row and try to see how to reduce this first row to 1, and then we maintain this 3, and then hopefully -1 and -16 is also maintained. So let's take this. We want to work on the first row. We want to work on this first row. So to make this first row 1, what we need to do is let's say we take -2 row 1, -2 row 3 plus row 1 plus the first row. This will give us 1. Then we will have 11. Then we will have -7, and then we have -26. What we have done is -2 row 3, that is -2 times 3 will give you -6 plus 7 will give us 1, and then we maintain the second row, which is we have 5, we have 4, we have 2, and then we have 4, we have 3, -4, 3 and 5. So this is what we have right now. This is what we have. Of course, we still need to demarcate this. Okay, so now that we have this, our target will be to make this second row. We want to make this second row, this particular 5. We want to make it to be 0. To do that, we will need to work on row 2. We want to work on this row 2, this particular row, and to do this, what we need to do here is -5 row 1, -5 row 1 plus row 2, -5 row 1 plus row 2. And if we do that, we will simply -5 times 1 will be 5 plus 5 will be 0. So let's see what we have in that particular position. So now that we are able to, we've already made this 0, so let's try to also reduce the third row first column to be 0. So what we are going to do here is let's take -3 row 1 plus row 3. So let's take -3 row 1 plus row 3. This is like say -3 times 1 plus 3. This will give us 0 here, and that is our target, so that here we will simply get 0, and here is -37. We'll have 24, and then we will have 83. So the next one here is to reduce also this -37 to be 0. And how are we going to do that? So here what we simply need to do is to reduce this -37 to 0, we simply need to divide. So this is -37 divided by 51 row 2, that is -37 divided by 51 multiplied by row 2 plus row 3. This will give us 0 here. So it is -37, divide this by 51 multiplied by -51 plus row 3, which is -37, and this will certainly give us 0 in this position. And for 24 we will simply have -144 145 divide by 51, and if we do this here, we will simply get this divide by that will give us negative 725 divided by 51. So let's have that down. So after having this down, the next thing we need to do now that we have reduced these three elements here to be zeros is to write our matrices now in the form of system of linear equation. And to do that, we will simply have here is 1, so it is x. Let's have it up here. This is going to be x plus 11y because we have 11 in this position, minus 7z, and this is equals to negative 26. We repeat this in the same one. We have so this is what we have, and we now need to do back substitution. We need to solve this back substitution in order to obtain the value of z, y, and x. And to do this, we simply have, let's start from here. Back substitution, we have negative 145 over 5z is equals to negative 725 over 51. So that will be negative, we have negative 145 over 51, and this is z. It is equals to negative 725 over 51. So we want to solve for the values of z. So z therefore is nothing but, when we cross multiply this, we simply have negative 36975 divided by, when you cross multiply this, you will simply get negative 7395, negative 7395. This therefore means that the value for z is nothing but 5. If we divide these two, you will simply get 5. We are using back substitution, so the value for z in this equation is 5. We need to now substitute 5 in the second equation, which is negative 15. So we will have negative 15y plus 37z. This is 37z, but now our value for z is 5, so we multiply this by 5, and this will give us 134. Sorry. This implies that if we multiply these two together, we will simply get negative 51y plus, that is going to be 185. When we divide both sides by negative 51, 185, this is equal to 134. Take this 185 to this side, you simply get 51. Therefore, our value for y is going to be equal to 1. Now we do the same in the first equation. Substitute 1 in y. This implies that the value for x is nothing but negative 2. So in this question, we've got the value for x